The point of this video is hopefully to explain the latitude and longitude coordinate system used to express our position on Earth. So all coordinate systems need reference points. So on Earth we have two obvious reference points, and that is one, the North Pole, and the South Pole. Now another reference is an imaginary line that splits the Earth in two, and that's this line, and this is known as the equator. Another reference, the last reference that we use, is a line that's drawn from the North Pole through Greenwich in London right round to the South Pole. And everybody who makes maps and charts and uses this system has agreed that this reference line runs through Greenwich in London, and it is known as the Greenwich Meridian. So I'm going to now express using lat and long this position where this X is. So the first thing I'm going to do is find out its latitude, and the way I do that is that I measure an angle from a line that's drawn from the equator to the centre of the Earth, and between a line drawn from centre of the Earth through our position. So now we can see that that angle is 50 degrees. So from the equator up to our position is 50 degrees, and it's towards the North Pole, so we say that our latitude is 50 degrees north. So we can also say that if we're on the equator we're at 0 degrees latitude, and if we're at the North Pole we're at 90 degrees north. So our position is 50 degrees north. Now I can draw a line from this position all the way around the globe, and anybody stood on that line anywhere is known to be at 50 degrees north. So the next coordinate is our longitude, and the way that we find that is that I'm going to measure an angle between the Greenwich Meridian, which is represented by a line from the centre of the Earth to the edge, to the actual meridian, and our position. And we can see that this angle is 70 degrees, and it's in a west direction. So we would say that our position is 70 degrees west. So the longitude of that position is 70 degrees west. Now, degrees are subdivided into minutes, and there's 60 minutes in each degree. So we would write this position as being 50 degrees, no minutes, and then they're subdivided into decimals, north, and our longitude is 70 degrees, no minutes, no decimals, west. Now we write latitude with 2 digits because you can be between 0 and 90 degrees north, or 0 and 90 degrees south, and your longitude can be between 0 and 180 degrees east, a north and 180 degrees west. So that's how it's written. Now what's also worth mentioning at this stage is how we measure distance on the surface of the Earth. And this is when we're navigating at sea. Now I've made this tape measure, and I've made it to suit this particular globe. So I've measured from the equator to the North Pole, divided it into 90 for the degrees, and we can check the latitude, 50 degrees. Now these increments are 1 degree, so that's 45, 46, 47 up to 50, and the distance between this degree, 45 and 46, represents 60 nautical miles on the surface of the Earth. So that is to say that the distance of 1 minute of latitude equals 1 nautical mile. Now the Earth is not a perfect sphere, so it's agreed that a nautical mile in metres is 1,852. But for navigational purposes, on the latitude scale of your chart, which runs up the vertical axis of your chart, you can measure distance directly from it. And then the unit of speed that we use at sea is knot, and that is 1 nautical mile per hour. So hopefully that's helped to explain the latitude and longitude coordinate system.